Welcome to a video on setting up a quadratic equation to solve an application. Consider example number 6. Set up the equation to solve the following problem. A box with a square base and no top is to be made from a square piece of cardboard by cutting 2-inch squares from each corner and folding up the sides. The box is to hold 6,272 cubic inches. How big a piece of cardboard is needed? So what we can do is sketch out the information that's provided. So our goal is to determine the size of the cardboard. So notice that again, the cardboard is a square. So let's define both the length and the width as x. And then our goal is to create a three-dimensional object out of this by cutting up 4 corners and then folding up the sides. So we do not know the dimension of this cardboard, but we do know that the side of each corner here is 2 units, 2 inches to be exact. And therefore, if this is equivalent to 2 and the entire side of this cardboard is x, then the sides of the box, once it's folded up, is x minus 4, since we're taking away the 2 corner pieces right there. So here we have a box where it's an open top and the base here is going to be x minus 4 since we're folding up the sides from that cardboard. This is also going to be x minus 4. And then the height, I made it a little too high since the height here is 2 inches only. This should have been 2. So just imagine the box is a little shorter. So length, width, and height. And the volume is given, which is 6,272 cubic inches. And recall that the volume, I'll use the letter V to represent that. For a rectangular solid, it's length times width times height. So again, the length is given as x minus 4. The width is also given, which is represented by x minus 4 as well. And then the height is 2. And the value of the volume is given, which is 6,272. And now I'm just going to move the 2 to the very front just to make this a little neater. X minus 4, we have 2 of those factors, so let's go ahead and call it quantity squared. So this would be the equation that's necessary to solve for the dimensions of the cardboard. Notice that it's a quadratic equation, and the best approach to solve the statement is to use the square root property.